bring your attention to a few issues with the species set covering problem, but also with other problems, and some sort of assumption that sometimes we do make. Species move. Generally, species are going to go from one parcel to another one, or at least attempt to do that, right? And we cannot assume that, okay, this species has been spotted in this parcel, therefore, you know, it's in this parcel, it's never going to move. That is not true. Think about birds, for instance, going from one place to another. Interaction between species. Well, so sometimes we can talk a little bit more about this, but there are species who are in conflict with other species, right? So they are basically fighting for the same resource. Sometimes there are species that work with other species, kind of an umbrella as well. So, you know, we need to take that into account when we can. How many individuals in each parcel? And I had actually pointed to that issue earlier. You can maybe spot a bird, but how often do you spot that bird maybe, or this group of birds within a parcel? So the frequency is also very useful to know. And then can easily be integrated in the objective function is the cost to maintain parcels. So not all parcels are the same. Even in the small example that I showed earlier, some parcels are very small compared to some others. So how much does it cost maybe to maintain, or even to maybe purchase those parcels? Those are, I think, relatively important points, and that often are assumed to be the same throughout. So let's keep that in mind as we are improving our models. Alright, I would like to talk a little bit about extension to the maximum covering species problem. First one is the importance of species. So not all species are equal in terms of weight and their importance. I'm going to come back to this one after a little bit later. Connectivity among parcels. That's something that is not taken into account. That, as I had mentioned in the class, is one of the important GIS functionality. Let's suppose you have two parcels A and B. Here they are adjacent to one another. This is of course a much better setup than the second one where they are separated. Who knows what's going there? Middle, maybe a highway, we don't know. Then the other one is, what if parcels have different costs? C subject. So not all parcels are the same size. Some may cost more to purchase or even to maintain. So we could technically come up with two objective functions, so bi-objective problem, a maximization of the species, of the number of species that can be set aside. That's typical of the MCSP. And then you can have a minimization of the cost to maintain these parcels. So if you put them together into a bi-objective, a bi-weighted objective problem, you come up with a trade-off that the number of species that can be predicted is going to be a function of the investment or the cost that is put for the reserve network. And typically you're going to have this relationship, right? As you increase the cost and you purchase more land, right, more species can be preserved, but at some point the increase will be marginal, similar to what other papers we have discussed. So now I'm briefly going to talk about the importance of species weighting. Okay, so as I mentioned, there are different extensions that we can do in the maximum covering species problem. One of them is what if the species have different level of importance, or right, some are more important than others in terms of maybe biodiversity. So what we introduce is the concept of species weighting. So for instance, you could have species which are endemic, so kind of native if you want. You have some that are widespread. You can have some that are threatened species, you have some that can be non-threatened species. And if you were to put this into some sort of a objective function here, right, you could try to maximize the representation of the species which are endemic and the ones that are non-endemic, and you would essentially give a weight to those. Again, you have to think, what do you want to prioritize, endemic species or non-endemic species? Are they actually conflicting, are they not conflicting? But this could be an approach where you have a bi-objective problem. So you can see that some very simple model, as I mentioned earlier, could be easily extended, right? And think about this for a final project, for instance. Take a simple model, make it work, and then see how can we expand. What are the assumptions that we could try to incorporate in our model to make it more realistic? So here's a simple example.